This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on derivatives of exponential and logarithmic functions. We're going to talk about this number e. It is a number, it is irrational, not expressible as a fraction, it is a non-terminating, non-repeating decimal. It's an important number, and we define it as the limit as n goes to infinity of 1 plus 1 over n to the n power. So for example, 1 plus 1 over 1,000, 1.001 to the 1,000 power should give us a reasonable approximation for that. And I plugged in some various values for n. If n is 10, 1 plus 1 over 10 to the 10, we get about 2.59. 1 plus 1 over 100 to the 100th, about 2.7048. Here's the 1,000 I mentioned, 1 plus 1 over 1,000 to the 1,000, about 2.717. And with 10,000, about 2.718. I've got the approximation for e out to that many decimal places, 2.718281828, and then the decimals change beyond that. And this is, again, a very important number because it's going to define an important function. And the function is going to be f of x equals e to the x. Remember, e is about 2.718. 2.718 to the 0 is 1. 2.718 to the 1 is, again, about 2.718. 2.718 squared, about 7.389. 2.718 to the third, a little bit more than 20. 2.718 to the negative 1, that would be 1 over 2.718, about 0.3678. 2.718 approximately to the negative 2, 1 over that squared, about 0.135. So I want to graph this, and we'll explain why this function is important. This is an exponential graph. E to the 0 is 1, e to the 1 would be 2.718, e to the 2 up there. So we have our picture of that graph. Why is this graph important? What is it about it that tells us something? And here's the idea. So the graph of f of x is e to the x is in the dark color here. E to the 0 is 1, e to the 1 is 2.718, or about 2.72. E to the second power about 7.39. You'll notice at each one of these points we have constructed a tangent line. So if we look at the point 0, 1, here is the first tangent line. And the slope of that tangent line is 1. At this point, it's telling us the slope of the tangent line is 2.718. So you'll notice the slope of the tangent line 1 matched the y value. The slope of the tangent line 2.718 matched the y value. Same thing here. If we make our tangent all the way up here at 2, 7.39, the slope of the tangent line is 7.39. Again, the slope of the tangent line matches the y value, which is the function. The slope of the tangent line is the derivative. So the derivative of the function is the same thing as the value of the function. So f prime is the same as the y value. F prime of x is the same as e to the x. So here's our big rule. This is what makes this function may be the most important function in mathematics. The derivative of the function e to the x is e to the x. It is the only interesting function that is its own derivative. The other function that is its own derivative is 0, right? If f of x is 0, f prime of x is also 0, but not terribly interesting. But the derivative of the function e to the x is e to the x, so all of the y values match the slope of the tangent line. So let's take a look at the derivative of 5x cubed plus 7e to the x plus 2. The derivative of the sum is the sum of the derivatives, so we'll take the derivative of 5x cubed plus the derivative of 7e to the x plus the derivative of 2. And we can also pull the constants out in front. 5 times the derivative of x cubed, 7 times the derivative of e to the x, which we have there. The derivative of x cubed with the power rule is 3 times x squared. The derivative of e to the x is e to the x. The derivative of 2, we think of 2 as a horizontal line. The derivative of 2 is 0. So we get 5 times 3x squared plus 7 times the derivative of e to the x is e to the x plus 0. And our final answer, multiplying the 5 and the 3. 15x squared plus 7e to the x plus 0. Of course, the plus 0 isn't necessary. And we get a final answer of 15x squared plus 7e to the x. Let's look at our next example. We're going to take a look at f of x as the natural log of x. Now, that is log base e. If we write natural log of x, that's log base e. Remember e again, about 2.718. Now, how are we going to graph this? What's our strategy going to be? Well, I'm going to think of it as y equals log base e of x, and just switching them, log base e of x is y. Starting with the base, e to the y power equals x. Then I can plug in various values for y to get x. For example, if y is 0, e to the 0 is 1, x would be 1, which is what I have here. If y is 0, x is 1. If y is 1, x is e to the first, about 2.718. If y is 2, e to the second, 7.389. Y is 3, etc. And this is the inverse of e to the x. The x and y's are switched. So the function f of x is log x is the inverse function of f of x equals e to the x. What does the graph look like? Like this. And why is this important? Or what does the slope of the tangent of this function tell us? Well, I've got two tangents written here. One tangent at 2 that is in blue, and the other tangent at 6 that's at green. Now, what are the slopes of these tangents? At 2, the slope of the tangent is 1/2, and we see how 2 and 1/2 are related. At 6, you'll notice the slope of the tangent is smaller than 1/2. It's growing more slowly. That slope of that tangent is actually a 1/6. So that hints what the rule is going to be, that the derivative, the slope of the tangent, is not the same as the y value as it was with the exponential, but will be the reciprocal of the y value. So there's our rule. The derivative of the natural log of x is 1 over x. So we'll take a look at the derivative of 7x to the 4th minus 3e to the x plus 8 log x. The derivative of the sum is the sum of the derivatives, derivative of the first minus derivative of the second plus the derivative of the third. Pull the constants out front, pull the 7 in front, pull the 3 in front, pull the 8 in front. The derivative of x to the 4th will be 4x cubed. The derivative of e to the x is e to the x. But the derivative of the natural log of x is 1 over x. That's our rule. So we get 7 times 4x cubed minus 3 times e to the x. Derivative of e to the x is e to the x. Plus 8 times 1 over x. 7 times 4 is 28. 8 times 1 over x is 8 over x. And our final answer is 28x cubed minus 3 e to the x plus 8 over x. The next type of function we're going to look at is f of x equals b to the x. So 2 to the x, 5 to the x, 7 to the x, 1/2 to the x. F of x equals b to the x. How do we find the derivative of that? Well, I'll give you the rule here. The derivative of b to the x is b to the x times the natural log of b. To prove this, you would need to use the chain rule, which will come up later in the course. So if we have the derivative of 3 to the x, that's just 3 to the x times the natural log of 3. It is not x times 3 to the x minus 1. A lot of students want to use the power rule, but the power rule is only for x to the n power, where n is a number, not 3 to the x, 2 to the x. The exponent is not a variable in a polynomial, so x to the n is different than 3 to the x. The derivative of 5 to the x, again, 5 to the x times the natural log of 5. The derivative of 1/2 to the x would be 1/2 to the x times the natural log of 1/2, and this is correct, but we can simplify this a little bit. 1 to the x is 1. 2 to the x is 2 to the x. So on top I have 1, on the bottom I have 2 to the x. But we also know that the log of 1/2, using our rule of logarithms, is log 1 minus log 2. So again, 1 to the x over 2 to the x is 1 over 2 to the x, log 1 minus log 2, but log 1 is 0. So if you feel so compelled, you can go ahead and rewrite this as minus log 2 over 2 to the x. A little algebra to make the answer look more pleasant. So let's take a look at this. We have the derivative of 9x to the 7th plus 4e to the x minus 7 log x minus 5 times 2 to the x. The derivative of the sum is the sum of the derivatives, derivative of the first piece plus the derivative of the second piece minus the derivative of the third piece minus the derivative of the fourth piece. Boom. We can pull constants out in front, pull the 9 in front, pull the 4 in front, pull the 7 in front, pull the 5 in front. Those are all constants. Now what are our derivatives? Derivative of x to the 7 is 7x to the 6th. Derivative of e to the x is e to the x. Derivative of log x is 1 over x. Derivative of 2 to the x is 2 to the x times natural log 2. So you see 9 times 7x to the 6th plus 4 derivative of e to the x is e to the x. Minus 7 times 1 over x minus 5 times 2 to the x log 2. 9 times 7 is 63. 7 over 1 times 1 over x would be 7 over x. And then we could just rewrite this as 5 log 2 times 2 to the x if we're so inclined to do that. So there's our answer, 63x to the 6th, or 9 times 7 plus 4e to the x, minus 7 over x minus 5 times natural log 2 times 2 to the x. That would be the derivative of this original function. Now the derivative of log base b, we did the derivative of natural log of x. Derivative of natural log of x is 1 over x. How about a different kind of base? Well, we know from the change of base theorem that log base b of x is natural log x over natural log b. Natural log b is a constant, so I can pull this out in front. I can think of this as 1 over natural log b times the derivative of log x. And the derivative of log x, natural log x, is 1 over x. And then I could rewrite 1 over log b times 1 over x as 1 over x log b. This is relatively easy to prove, so I kind of like to do that. But that's our process of finding the derivative of log base b of x. So here if I have the derivative of log base 3 of x, I'm just going to write it as the derivative of natural log x over natural log 3. Pull the natural log 3 in front. 1 over natural log 3 times the derivative of log x. The derivative of natural log x is 1 over x, and we multiply that together to give me 1 over x log 3. That's showing all the steps. If you want to take the derivative of log base 7 of x, if you want to just jump to the final answer, you could say that that's 1 over x times the natural log of 7. So that's fairly easy to remember. Okay. Our next question will be then the derivative of 6x squared minus 5e to the x plus 8 log x minus 9 times 4 to the x plus 2 times log base 5 of x. So we're going to take the derivative of the first piece minus the derivative of the second piece plus the derivative of the third piece minus the derivative of the fourth piece plus the derivative of the fifth piece. Pull the constants out in front. 6 comes out, 5 comes out, 8 comes out, 9 comes out, 2 comes out. The derivative of x squared is 2x. The derivative of e to the x is e to the x. The derivative of natural log of x is 1 over x. The derivative of 4 to the x is 4 to the x natural log of 4. The derivative of log base 5 of x would be 1 over natural log 5 times 1 over x, or 1 over x natural log 5. And then simplifying these things, 6 times 2x is 12x. 8 times 1 over x is 8 over x. I might rewrite this as 9 times log 4 times 4 to the x, and 2 times 1 over x log 5 would be 2 over x log 5. So again, 6 times 2 is 12. 5e to the x doesn't change. 8 times 1 over x is 8 over x. 9 times log 4 times 4 to the x. Make that look a little cleaner. 2 over 1 times 1 over x log 5 is 2 over x log 5. And that will conclude this lesson.